Good afternoon, everyone. Welcome to today's event, Certified Imagery for GIS and Planning Professionals. I see some folks still trickling in, so I'm going to give this just 30 seconds or so as hopefully a few more will join us. I see some familiar names on here so far, so I appreciate you all joining us. All right, well, I think I'm going to go ahead and get started here. So again, thank you all for joining us. We're going to kick off the session here. Appreciate you all joining us for the event this afternoon, Certified Imagery for GIS and Planning Professionals. My name is Kevin Beers. I'm the District Manager with EagleView based here in Texas. Certainly excited that you could join us for kind of an in-depth look at the benefits and applications of certified, high-resolution ortho imagery. And also look kind of behind the scenes to see what actually goes into producing this type of imagery. So kind of give you a lay of the land here. I'm joined this afternoon by a pair of our experts from the EagleView team, Emma Witherwax and Carl Schoenthal. Emma is a aerial triangulation or AT manager here at EagleView, and she'll be providing some insight into the processes we use to actually produce certified imagery. And then we'll turn it over to Carl. Carl's our Senior Director of the Professional Practices Group, and he'll be kind of addressing the considerations related to building a certified imagery library. So we'll turn it over to Carl here towards the end. We've got a full agenda, and of course we want to leave time for questions, so please feel free as we go through. You can submit questions. So before we get started, just a couple of housekeeping items. We want to make sure this is a positive experience for everyone. So first of all, you may have already discovered that the screen is customizable. So essentially you can move things around. You'll see there's arrows where you can resize things and so on. So feel free to arrange things to your liking. And again, if you have questions, you'll see there's a Ask a Question button. So feel free to submit your questions there. We will certainly have time to address those as we go. We'll take a little bit of a break about halfway through, and then of course at the end we'll address any remaining questions. There's also a related content box that has some additional links that you can refer to, and also a survey where you'll see there are some questions that we've posted so that we can better understand what your needs might be. All right. So here's kind of the overview, right? Here's the plan of what we're going to cover. You're going to start with me. Sorry, you're going to have to listen to the sales guy here for a few minutes. But what we're going to do is start out with a brief overview. Essentially, what is an orthomosaic? Many of you are familiar with that, but just to touch on that for those that may not be familiar. So that'll kind of set the stage for the rest of the discussion here throughout the session. And then I'll move into a description of our specific products that we're going to focus on here today. But then the real action, right? The real excitement kicks off. I'm going to turn it over to the experts, Emma and Carl, to kind of dive into the process of how these products are created. Then some of the use cases, right? What is this certified orthomosaic used for? And then finally, we'll touch on some of the next steps of, how this can help with your needs and where this product may fit into what your workflows are. All right. So to kind of set the stage, before we dig into the topics that we're going to jump into here in a second, I want to kind of give you the lay of the land in terms of the EagleView product landscape. And there's a lot of terms here, so I'll run through this just briefly at a very high level. But you'll see these names: Reveal Essentials, Reveal Essentials Plus, and Reveal Advanced. Now, these are essentially just product names, right? Anytime you work for a company that has a marketing team, they're going to put branding on the products that you release. So if you think of this, though, they build on each other. So Reveal Essentials is essentially our standard ortho imagery. And then as we move to the right, Essentials Plus adds in the oblique imagery, right? What EagleView is really sort of known for. Going back, 2 decades at this point. And then Reveal Advanced, you're adding on the certified ortho, but also 4-band, right? That color infrared. So that's kind of the progression of products as you go across our reveal product line. There's a couple of different resolution choices. You'll see the term property and neighborhood that refers to 3-inch or better and or 6-inch or better. And then along the bottom, you'll see some of the additional add-ons that, again, are included within the advanced product. But in terms of the Essentials product, the ortho-only product, and the Essentials Plus, which includes the obliques, these are add-ons where they can be included or not included, depending on what the needs of your particular use case is. So the two that we're going to really drill down into today are these two add-ons here, the Certified Accuracy and then also the True Touch. So that kind of gives you the big picture of what we're going to look at, and now we'll dig into that here as we go a little bit. Okay, so in terms of an overview, right, the first question that obviously comes to mind is, what is an orthomosaic? And I'm going to obviously leave this to the experts to dig deeper into, but at a high level, right, this is an imagery product that represents what's on the ground, right, the geography of a particular area. I think we're all familiar with this more so than maybe in the past, just because of things like Apple Maps and Google Maps and so on. The process of creating these orthomosaics is really fairly simple in terms of conceptually, you're taking a whole bunch of small images and you're making them one big image, right? You think of going back to when you were a kid, right? You're a child and you're taking pictures and creating a collage, right? That's essentially what a mosaic is, not to oversimplify it. But we're taking a whole bunch of individual frames, individual pictures, and processing them to create one big image, as if you were taking this with a very large camera covering a very large area of the Earth, right? A geographic area. Now, what really I think sets EagleView apart are these next couple here, right? Very high resolution, and then the precision that we have when we go through this process, right? So again, I mentioned Apple Maps and Google Maps. You get a consumer grade product that is designed just to show you what's out there and maybe get you from one location to another. But when you move into the certified realm, that's where we get the high level of accuracy and precision, and obviously the resolution, right? Getting down to 3-inch or better resolution. Okay, so again, drilling down into those two products that we mentioned, we've got the certified ortho and then also the True Touch. So in terms of the certified ortho, what does that really entail? Well, that's an authoritative orthomosaic that's produced to any specifications that are required, right? And those specifications are typically either from the state or local level. There's also standards out there from various professional organizations and so on, all around what level of accuracy is required in order for this product to be what we refer to as authoritative. And in terms of context, when you think about what does authoritative really mean, from our standpoint, from EagleView's licensed professional standpoint, they really define authoritative as a work known to be reliable because its authority or authenticity is widely recognized by experts in the field, right? And that really goes back to who's setting those requirements, those standards that orthomosaic needs to meet. So if those experts recognize that you've gone through the process and produced this product to a certain level, that becomes an authoritative product, right? So how is it authoritative? What makes it authoritative? Well, it's really the process that you go through to produce the product, and then also how you document that, right? The methodology. So with a methodology in place to develop a certified ortho product by licensed professionals, they can replicate that. So if you've done your job right and produced this product to certain standards through a certain methodology, if they were to follow, someone else were to follow those same standards, the result would be the same, right? You'd result in the same level of accuracy. Now switching gears to True Touch. Now this is kind of part two, if you want to think of it that way. Now these are the visual enhancements, or I often refer to it as the manual corrections, right? So when you're capturing a whole bunch of images and you're stitching them together, creating these mosaics, you're going to have anomalies, or you're going to have things that don't look very good for various reasons, right? you're going to have bridges that seem to collapse down into the creek bed or the stream, right? Because of the elevation model that's used, right? You're going to have buildings that kind of collapse in on each other, or in this case, they balloon, right? They're bigger at the top because they're much closer to the camera sensor, right? Well, these things all take away from the visual appearance of that image, right? You need to be able to see the sidewalks and the roadways that are next to these buildings, right? So you can't have buildings that are either collapsing in on themselves or again, ballooning to obscure some of these features. So the True Touch process is where we manually go through and correct all of these types of things. And again, not to steal the thunder from Emma, but she's going to run through and show you a lot of these situations here as well. So some of the advantages of, again, a certified orthomosaic, as you can probably imagine, it has that positional accuracy that's often required for certain scenarios, right? If you're in the engineering field or doing planning for road or bridge projects, you may need a different level of accuracy than if you're a property appraiser or if you're in the 911 industry, things along those lines. So the accuracy is obviously improved by using traditional ground control points, right? Those surveyed points where we capture them with a GPS unit, or we're using photo identifiable points in an image where we know what the actual coordinates are of that location, and then we process the imagery with that to improve that positional accuracy. You also have those manually corrected visual effects, right? So you're getting rid of those cut lines and those funky things that can happen with buildings and elevated structures. So when you're looking at things like drawing planimetric features, right? Street center lines, curb lines, impervious surfaces, driveways, parking lots, it's helpful to not have significant cut lines and variations in imagery as you're going through and identifying where those planimetric features are. And then same with mapping, right? So any planimetric feature, but also just in terms of maintaining your mapping and GIS program, right? If you maintain, again, street center lines or even address points that show, locations of doorways or entryways for 911 purpose or search and rescue, all of those types of features are enhanced because of the positional accuracy, and then of course the visual appearance of a certified ortho product as well. So FGDC compliant, this comes into play, particularly if there's federal funding involved, but also this is kind of the uniform standard of, preparing metadata that meets certain requirements. And, if you're producing a certified product for an agency that has utilized or worked with certified imagery in the past, obviously they're going to look for this kind of, seal of approval, if you will, to go along with it. And then also we provide a certified accuracy statement that, again, speaks to those local standards, basically documents that this imagery meets or exceeds those standards, and again, identifies the methodology that was used to replicate that process in the future. Apologies, I hit the slide here a little too quick. So, okay, so lastly, what I wanted to touch on was just a few examples from here in Texas. I wasn't going to throw any names on here to give it away, but I think most of y'all probably know where the Toyota Center is. But again, these are just snippets of a few images that we've produced, and you're going to see a lot more examples here as we go through. I think I've got one more example here as well. I think everyone's probably familiar with that image on the right as well. All right, so with that, those are the products that we're going to look at today. So I'm going to turn it over to Emma now. So Emma's team is responsible for creating these products. So I'm going to turn it over to her, and she's going to dive a little bit deeper into kind of the behind the scenes as far as what the process is to go through and produce these products. So with that, I'm going to turn it over to Emma.
Wonderful. Thank you, Kevin. So to get started with the process, while an orthomosaic is a really simple concept, actually creating one is a bit complicated. So what you're seeing here on your screen is a very high-level description of our workflow. It begins with the preparation of imagery for aerotriangulation. We work through the post-processing, orthorectification, and mosaic creation process. And once we have that orthomosaic, that's when the TrueTouch team steps in to use their detail eye and skill to address some of the concerns that Kevin just showed you a few slides ago. So to start off with our imagery preparation for aerotriangulation, first things first, we're going to get into color balancing. And color balancing, or equalization as we call it, is applied across the image data set. It's going to reduce the color contrast and limit areas of high exposure. As you can see in this example image on your screen, you've got the before in the top and your after in the bottom. And if you take a look at the before, you can see the difference with the mosaic hasn't had that color balancing process applied to it yet. You can see image footprints in the water, in the inlet, and those are areas that are naturally going to have more reflection and color variation between your flight lines. But of course, at the end of the day, we're getting to this seamless product, so we want to color balance to reduce the color contrast and limit areas of high exposure between the images. That brings us down to our last bullet, where of course we have our wonderful TrueTouch team, but that's a lot of manual work if we didn't color balance and kind of even out that image coloring that would need to be addressed during the TrueTouch process. After our color balancing, that's when we move into the actual AT that my team does. The AT portion of our workflow begins with an automated process that directly supports the relative accuracy or the positional consistency between data points. So what you're seeing here in the image is the process locating like pixels in overlapping image frames. It's pixel matching between those overlapping frames, saying this pixel that I have in this image is the same as this pixel in that image. This must be the same location. The example on screen is a single image that has gone through our tie point generation software. And as you can see, there's probably more than 100 tie points in that image alone. So these automatic tie points are not things that we could manually place. They're not things that are easily identifiable by the human eye, which works really well when, as in this example, we've got farm fields maybe, or very heavily vegetated forest. We can't necessarily pick out the differences, but the software can pixel matching together. So the images are tied together through this process, and that's going to alleviate any misalignment between adjacent images, making sure that your frames are lining up to one another. After we've gone through our tie point generation process, that's when we measure our surveyed ground control. So initially, ground control points, or GCPs, are measured by licensed surveyors out in the field. There are pre-selected locations that we determine here internally, ideally at high contrast sites that have a clear visibility from the sky. So think in this example, maybe a sidewalk corner, a driveway corner, let's see, a painted stop line, things like that. The goal is to have something that's a clear view of the measurement site in the imagery, free of any obstruction like tree canopy, building shadow lean, maybe a parked car, things like that. We want it to be really identifiable both in the real world and in our imagery. The surveyor goes out into the fields and they collect a highly accurate GPS coordinate of each ground location and a photo, as you're seeing here. Those GCP locations are manually measured then here in office at the same location in the imagery, saying that point in the real world is here in our imagery. Those measurements are used to improve the absolute accuracy of our product and support image adjustment to the real world ground location. Combining that imagery that we've fed into our AT system, the tie points that we've generated, and now the measured points from our licensed surveyors, we move into our post-processing procedure, which requires the image data set be run under a series of standardized settings. So we do a number of unique post-processing runs to both confirm and improve both the relative and absolute accuracy of the solution. So improving the accuracy to the real world and improving frame-to-frame accuracy as well. Our AT process is complete once we have a refined and approved set of exterior orientations that have been achieved for each frame. That's something that our licensed professionals are signing off on. Again, we said that kind of authoritative process, we're always hitting the same series of standards with our imagery. After our AT process, we move into our orthorectification process, and that's going to bring together the adjusted EOs from our AT solution, the digital elevation model, and from there we create an ortho image data set used in our mosaicing process. So a digital elevation model, or a DEM, as you're seeing in the middle of the image here, is used to accurately georeference an aerial photo. The DEM is going to remove any image tilt, terrain, and create a distortion-free image. During this orthorectification process, images are also remapped to north up, and that orthorectification process leaves us with an ortho image data set that we're going to use in our mosaicing process to create our ortho mosaic. So in that ortho mosaicing process, we are ready to start our kind of long and complex processing of a mosaic. The images are going to be stitched together into a composite tile using the overlapping areas of the images as reference points. So what you're seeing on your screen here, the image on the right is a zoomed in version of the mosaic tile on the left. And those black polygons, those are illustrating the use of our building outline hints. They guide our seam line process around the polygons, minimizing any breaks in houses, buildings, and it's going to greatly minimize the amount of work our TrueTouch team would have to do if seam lines were just randomly cutting through every single building. And we'll talk about why that would be true as we get into our TrueTouch process. So in the top right corner, what you can also see is two image frames. Those are demonstrating the overlap and the perspective size of images stitched together during that mosaicing process. So in any one tile, we could have 50, 100 images stitched together to create that high resolution tile that you see here. So once we have created this ortho mosaic, that's really when we move over to our TrueTouch team. And seam lines are generated during that mosaicing process, and that's what the TrueTouch team is going to use to help guide any corrections that need to happen. You can see here in the white lines in the image, those are our seam lines, and they're actually, you can see how the building outlines have helped steer the seam lines around really dense urban structures here to prevent those manual reworks that might be needed. The TrueTouch team is going to enhance our orthogonal imagery by removing any evidence then of the seams or distortions in the orthomosaic and improve that viewing quality like Kevin was describing before. The process enables accurate representation across all features, so our roads, bridges, large buildings, landmarks, and it's going to be a really extremely detail-oriented manual process that we'll get into now as we go through some of the most common fixes. So our TrueTouch team does a number of different fixes that might be something that they'd come across. What you're seeing here on your screen is one of the most common ones. Large buildings and complex structures. We've got the Boeing factory in our image here, and as you can see from the seam lines, the structure is far larger than any one image. We can't fit this entire factory in a single high-resolution image. When a building is hit by a seam line, though, the building is naturally going to break, as buildings are elevated structures and the two images are taken at slightly different times, from slightly different directions, and they're just going to lean slightly different ways then as the plane flies overhead and captures your imagery. So our TrueTouch team will go in and manually fix that building again, so you can see all the ground around your building and you don't have those manual breaks. Next up, we've got our bridges. So bridges, much like buildings, are large elevated structures. As you can see in this example, the bridge spans multiple images and doesn't fit into a single image frame. So the mosaicing software has to use multiple images to stitch it together, But again, taken from different times at different locations, the perspective on that elevated bridge is going to be slightly different for each image, resulting in different sections of the bridge leaning in slightly different ways. You can see here in this image, we're kind of leaning a little bit to the north, while other sections might be leaning a little southward. So we'll use our bridge fixing process to correct those and have a seamless bridge structure. Next up, this is an example that Kevin just walked you guys through with our building lean. So customers are typically interested in seeing the ground coverage in their certified ortho product rather than one side of the building. They want to see road conditions, fire hydrants, all different things. But for a tall skyscraper, if the mosaicing software chooses an image that's not quite nadir or straight down over that building, it's going to look like your skyscraper is leaning one way or another. To repair this issue, our TrueTouch team is going to manually choose the image that is most nadir and not leaning over our ground features. We've also got things like time of day or cloud shadow. We're going to correct those radiometric differences by selecting a different area using alternative imagery or updating the exposure as needed. Water is another common one. Water is constantly moving, changing. The reflection is going to be different depending on where the plane was in the sky, when it captured versus how the sun angle was hitting the water. So as you can see in this image, our water doesn't always have the same reflection frame to frame. Our TrueTouch team can go in and blend that out so it looks like one continuous surface. And lastly, any broken buildings. We talked about building outline hints that we use in our mosaicing software. If they're not perfect, a building could be missed, or as actually what's happening here in this example, this break is actually due to the edge of an image being hit. So what we've got here is a single straight seam line right through that house. That happens because the mosaicing software used all the way up to the edge of the image and it didn't have any more image to go. So it had to use another one. But again, buildings are elevated structures. And when we've got that different perspective, frames taken at slightly different angles as the plane is flying overhead, that is when you can result in a building break. And our TrueTouch team will correct this by using a single image that covers a building. After an extensive QC process and making any necessary fixes, the TrueTouch team then takes over with making any final deliverables according to customer specifications, different file formats, tiling, projection, anything like that. And that is where our TrueTouch team leaves off. So I'm going to pass it to Carl in a moment to discuss use cases. But before we do, I want to pause and address any questions that may have come up.
Yeah, thank you, Emma. Fantastic. I don't see any questions here yet, but I'll give you a quick second. Feel free to type in a question there before we continue. I find it fascinating, as many times as I've heard the process, I'm familiar with the process, but going through that, it reminds me just how mind-boggling it is, the number of tie points that we work with and the manual corrections, just the amount of work and effort that goes into that. So a big thank you to Emma and her team for running through that. Okay, so I don't see any questions at this point. So Carl, I'm going to go ahead and turn it over to you.
Thanks, Kevin, and thanks, Emma, for all the good work that you've done and continue to provide to our teams on all these projects. I'm going to speak a little bit to the use of these ortho images and what kinds of programs are necessary to support their use throughout an organization. As you see on the slide here, Imagery is a critical tool for making well-informed decisions and helps to reduce the field work that's performed either by citizens or professional staff in your organizations to answer these critical questions. Imagery supports government services, commercial and private endeavors, and the 3-inch resolution increasingly is becoming a standard for government and GIS applications. high resolution is super important, super critical to being able to really make some good decisions, and having the high accuracy associated with that image in addition to high resolution becomes the basis for many GIS applications and modeling programs and change detection processes that are also solutions that we offer at EagleView. And the reason these orthoimagery programs are starting to become pretty common, within government organizations and private practice is that there's just been so many major improvements that have allowed us to be able to produce these products at very high level, high quality level, high resolution, and high accuracy. Digital camera sensors now are capable of collecting this higher resolution imagery, and there's sensors that now collect additional bands of imagery, including near infrared. Usage of the combination of what's available now in the airborne GPS that's on board the planes that fly, the continuous operating reference stations that many DOTs and other agencies have established on the ground, improved navigational data processes, just means that we can rely on those technologies now to produce higher accuracies and get more regular consistency with how they're produced. And then faster imagery processing workflow and tools allow us to do a better job with our QA/QC. So in some instances, there's projects that we produce where a third-party entity will be involved in reviewing the deliverables of a project, and they're able to turn those reviews around. We've been very successful in meeting not only the standards, but also the high degree of expectations that our customers are looking for us to produce. And one of the reasons we can do this is because we have a unique sensor that is proprietary to the EagleView family. When Emma showed the picture of the images, image frames side by side overlapping each other, the white rectangle on the inside of this darker gray image is the actual footprint of a smaller frame camera that we utilize, which allows us to have a more nadir or more vertical perspective of the ground. When you're dealing with providers that offer large format mapping camera, while they may be more cost effective or more efficient at producing imagery of this kind, they're also expanding their field of view, and you're not getting as much of a nadir, true up-down view of the ground. And so our image frames that are used within that mosaicing process are the most nadir that you could expect to get for the different sensors that are available on the market. Certainly there's a purpose you'd have a large format camera if you're doing agricultural work or doing certain use cases there. You're trying to get a high volume of collection, and you're not so concerned, or the criticality of resolution and accuracy aren't as critical to the project. There are applications where that makes sense, but we found that this has been a good fit for us to offer this camera orientation and use this system, because it allows us to have a high quality process, reducing lean, occlusion, and displacement, and the exposure fall off that comes with alternative sensors. And again, an example that Emma was showing here, if you look at the left versus the right, situations where you have a number of taller structures, the whole purpose of the ortho image is to be able to see the ground. And if you're using a camera that has a much wider field of view, you're going to be missing quite a bit of the detail that occurs on an image on the ground, getting more to a truer ortho view than otherwise available. For those that are interested in putting together, the specifications and standards within your organizations, there's some useful tools that are out there, standards that have been published. This is the 2014 version of the ASPRS standard for digital imagery. And as mentioned at the beginning of the program, we offer a property level, a 3-inch, and a neighborhood level 6-inch product. And each of these are able to be produced up to what's considered 2-pixel accuracy. So If the image size, the pixel size is 3" by 3", that's your ground sample distance, which is equivalent to a 7.5 centimeter pixel. We have the ability to produce regularly a 15 centimeter RMSE X and Y, which is reflective of a 2-pixel accuracy, which is recommended for all applications where standard mapping and GIS work is being conducted. So we have a solution that doesn't include the high accuracy work, which is more for visualization, less accurate work, but this certified imagery using ground control and the AT process, as Emma has shown, gets us to a level that's for standard mapping and GIS work. Now, certainly there's projects that can be produced that go even higher on the accuracy spectrum for highest accuracy work. But in our discussions with many transportation departments and customers, counties and others, they find that the 2-pixel product is a good, high quality solution for them that they can use to build their GIS mapping and have confidence that what they're producing has a high level of accuracy. You can also take that 2014 standard, and again, here's our 3" and our 6", and compare it to the equivalency of past specifications and standards. So National Map Accuracy Standards and the ASPRS 1990 standards. And of course, 1990, I think I got my first email in 1990. So we weren't dealing with digital imagery at that time. And back in 1947, when the National Map Accuracy Standards were put out, we were strictly dealing with post-war imagery collection. So the 2014 standard, which is what we've referenced here and are working towards compliance against, is a high-level standard related to digital imagery collection, and is the one that you want to be using when you're comparing products across the industry. Multiple use cases for this product is a true representation of the ortho view of a site. Let's say doing assessment work, certainly our obliques, which provide views of the fronts and sides and backs of structures, is very useful, but you can also make high accuracy measurements, roof outlines, do a structures inventory and building measurements in a high accuracy fashion. Engineering applications include water, watershed collection, project design, high accuracy mapping for your GIS applications. You know that what you're referencing when you reference the image is within a 2-pixel accuracy of where that location is on the ground. With a high degree of confidence, you could be using that as your base imagery for your GIS programs and updating past GIS data sets that you may have developed over the years. Parks and recreation, being able to ground truth features, inventories, again, mapping and measurement capabilities, very important. Planning, land use analysis, roads, infrastructure, permits, planning. In your public works departments, looking for inventory mapping, asset management, right-of-way delineations, and again, project planning. Transportation, we're looking at infrastructure planning and project planning and mapping. All facets of an infrastructure mapping program and departments within your organizations will find value in utilizing this product. Now, certainly there are available products, provided elsewhere that are consumer grade or maybe for a different kind of program. Certainly there's value in having access to those data sets, but when you really get down to the day-to-day workload and the efforts that you put into the work that you do, having this high quality data set is certainly very helpful. So one of the things that we try to encourage users of this imagery to do is just be very thoughtful about what your needs are, and it's going to be critical that defining the needs and being able to communicate those out to those that are funding these programs. It's important to have very high quality presentation and program with respect to that. So in the case of engineers public safety, the value of high quality, high resolution data, and the increased use of that with the applications of how they plan to use that. Planning and appraisal departments are preferring the higher resolution imagery. So if you can get higher resolution and high accuracy, you're meeting the needs of both groups here, which may have some competing interests or competing desires in terms of what they might be looking for, which may sway a program one way or the other. So having pre-acquisition planning is extremely critical. So getting commitments from all participants before signing any contracts, understanding the funding mechanisms that may be available to pull the funding in to support a program like this. And larger projects will tend to overburden staff resources. So putting together a technical advisory council or a team, stakeholders that can be used to help put a program together within your organization. You certainly want to have a strong technical foundation for your projects, having good, strong survey control and elevation data, as was shown, having quality ground control that's been signed off on by a licensed professional, and having a digital elevation model will certainly, and more current digital elevation models, that be LiDAR or other source of 3D modeling, will certainly allow you to have a high degree of success in following the standards and achieving the accuracies necessary with your project. So survey control, target visibility, point accuracy, these are all things that we work with the project team to make sure that we meet these standards. When you have control that's been gathered over the years by a number of different participants, say land surveyors are submitting data in, and it's not related to a control network, sometimes that leads to some issues. A digital terrain model is needed to account for elevation warping. So just be prepared that there's a lot of this sort of foundational data that you're building within your organization that's really fundamental to getting high accuracy ortho program off the ground. Understanding what is considered acceptable and the value that's brought to the organization is super critical. So developing use cases that just include a description of how the imagery data can demonstrate cost savings. We certainly can help you with that. We've seen examples of this in other places. Developing this needs analysis consists of visiting the different partners that are going to be part of this process, finding out how they'll use the data. And those that are more active in using imagery will certainly begin to find more ways to use the data. So we offer a lot of training and a lot of opportunities for learning. So your GIS groups and your mapping professionals in your organizations are going to be super helpful in helping in communicating what their needs are and what kinds of applications they expect to get from the imagery. So high imagery, high resolution and quality imagery, we want to make sure we suit the needs of those key stakeholders. You want to have an availability of an effective data distribution system that's online and easy to use. So you don't want to just end up with a hard drive of information that you have to figure out a way to implement that within the organization, but there's ways to serve up this software through the cloud and through other mechanisms, other platforms that you certainly can help figure out a way to make that as cost effective and distribute this imagery as much as possible. And imagery can be integrated into a number of business data systems. So your CAMA systems, permitting systems, computer-aided dispatch, all towards the intent here to improve the efficiency of these business processes that are being performed. A lot of times we find that approaching a project like this, because of the sheer effort that goes into developing the project, the cost of it, and the expected benefits, requires putting together a team within a diverse organization. So a consortium approach we found to be very successful in a number of large municipalities, county levels. Have multiple agencies that are able to put some money into the pot to help build this program. So connecting, at all to the political process at the highest levels is important. Strong networking, setting up user groups and organizations that start talking together and understanding what their needs are and how they can best be served by this. Strong marketing at conferences and community events. Strong emphasis on marketing of the imagery benefits. Seek funding by partners who are strongly vested in GIS and the data acquisition. Show how the program's collective approach increases the return on investment for all those involved. And establish a clear business operational model that's clear and straightforward, and a clear and structured MOU so that you have clarity on the different relationships that have been established. Using a standards-based and professional procurement process is important in the state of Texas. These are professional services, and a qualifications-based solicitation is required. So you have a well-defined document. It may take some time to develop that, but we've got the tools to assist, and there's standards out there that you can reference. Using the latest standards, understanding the technology can be somewhat daunting, but there's certainly tools out there to help. So developing specifications that are well suited to all the different needs. Establishing performance standards in delivery and quality. Successful delivery of data can be defined in the specifications and the memorandums of understanding between agencies, and consider preparing contracts that are using longer term terms. It's a lot of effort to put together the structure of a consortium, put together the structure of a project, and as soon as you get that done, you get the imagery delivered, then you're already looking at the next round. So we have a lot of projects that are 2 years, 3 years, multiple captures over a longer period of time. It helps you to develop a working relationship with the vendor, and expectations of the time frame and the accuracy and the quality, as well as repeatability of the process and being able to rely on that. And also just develop excellent working relationships. Simplify the documentation then as much as possible through using standard MOUs, contract specifications that remain consistent over a multi-year period. So we're in this period right now where there's a lot of uncertainty. We've got cost impacts that have just been really last couple of years we haven't really anticipated what the last 3 years would be like, but having longer term contracts are extremely important to be able to lock in the savings and the value that you've developed your program around. So it's important to spell out the what, when, and at what cost when developing these MOUs. Plan for sufficient time to accomplish all this, and understand when the flight seasons are and have enough time to put things together. We see a lot of times where a pilot project is requested. A lot of times that's not necessary. Simply we have other projects that you can look at and evaluate to determine if the quality level and what you're looking for from resolution and accuracy standpoint is sufficient. And a lot of this has become much more standardized in the approach that we take. There's certainly lessons learned that we've had over the years doing this. I think this is I've been doing this for over a decade, following this process and applying the new technology year over year. Prepare a well-defined specification, consider regular updates of those specifications and considerations for new technology as they come online. Refer to the most current appropriate standards and specifications. ASPRS 2014, which you can Google online, is your best source and reflects a sensor agnostic approach to mapping projects. So you have the ability to do a qualifications-based solicitation and also guarantee that you get the accuracy and the quality levels that you're looking for. Work within your organization to develop a project management approach that takes into account project risks, regular communications that set realistic expectations, deliver the data on time and with the highest quality. Multi-agency approaches where you include federal and state involvement that tends to complicate and delay certain projects because there's extra considerations that have to come into play, a lot of different factors that come in. So if you have the ability to put together a consortium and obtain stakeholder requirements and communicate that within the group, as long as you're making it equitable and you can justify the differences in cost between the group, then you're well on your way. And build trusting relationships at each opportunity. Just a few last lessons learned here. This long-term price stability is an especially important thing to consider at this stage, as the way the world is, the economy, and things are playing out here. You want to have predictable recurring program that gives you benefits not only this calendar year, next calendar year, but years ahead. So there's opportunities for that long-term price stability where you need it. Fixed prices create budgets that you can then, everyone within the consortium can plan what's their expenditure going to be over a period of time. Consider training and technical services. Each organization that's involved in the preparation of these projects can provide you technical support. And so managing those vendors through the technical support provided, most clients we find don't want to spend the time to analyze in detail the technicalities of the imagery, but just rely on the fact that the specifications and standards that are utilized meet their obligations. And certainly the professionals that are working on the team are there to also validate and give you the assurance that the work that's been done meets a high degree of professional standards. So with that, I'm going to turn it back over to Kevin and be prepared to help answer any questions you might have.
Thanks, Carl. I appreciate it. Great information there. Just a reminder, I don't see any questions yet, but I'm gonna blabber here for a minute and allow you to submit some questions. Again, you've got the option there to ask a question, so please feel free to do that. So while we wait for a minute, see if anything comes through. Obviously, my contact information is on your screen there, so you can certainly reach out in the future. I would just add, to kind of piggyback on some of what Carl touched on. I would encourage you to, leverage us as a resource, right, for any aspect of the process, right? Whether it's, on the early stages of trying to build a consortium, all the way through to the procurement side and anywhere in between, right? If we can be that technical resource, certainly if there are questions that I can help with, but I can also reach back to Emma and Carl and the rest of our team to get insight into any aspect of the project, right? So as you're developing specifications or, again, getting interest from different parties and illustrating what use cases may be to various groups, leverage us. I would encourage you to reach out, and we're happy to set up webinars and phone calls and meetings and, help you pursue this technology, these solutions, if it'd be helpful for your jurisdictions. So with that, let me check the questions here again. Okay, well, I don't see any questions. So with that, we're going to give you back a few minutes of your day here. But again, I want to thank you all for joining us. A special thanks to Emma and Carl. Fantastic job. We will certainly send a follow-up, I believe, with a recording of the session here as well. So feel free to review that should you need it. And again, follow up with any questions. It looks like Carl has something to add here.
I see a question that just popped up here in the Q&A box.
Okay, question. How can I make the ortho images when using ArcMap much better? I have the pictometry tool installed to ArcMap. Well, and we may need to take this offline, but if the question is in terms of making the images better on the front side prior to delivery, that would be a process of migrating from the standard ortho that we kind of touched on to this certified ortho product, again, that goes through the using ground control and the manual corrections. If it's more a question of just adding it into ArcMap, we certainly can help with that. Stephen Ross, who is not presenting here today, but is my colleague here in Texas, he's our technical manager. We certainly can loop back with you and make sure that you've got the latest add-in and everything is working okay for you. So I certainly can follow up and make sure you're all squared away. So I'll make a note of that and we'll absolutely follow up on that. Any other questions before we wrap it up here for the day? Okay. Well, I think that's it. And again, we really appreciate your time. We hope this was informative and provided some information that maybe you were aware of, maybe you weren't. But in either case, we appreciate your time. And again, thanks to Emma and Carl for joining me here this afternoon. And we want to wish everybody have a great day. Take care.